Medical technology innovation with an organization well known for its research in fusion energy, but here they are. This award goes to the U.S. Department of Energy's Princeton Plasma Physics Laboratory, which was selected for a 2016 Edison Patent Award for its patent titled Production of Radionuclide Molybdenum-99 in a Distributed In Situ Fashion. Let's see the film.
My name is Charles Gentile. I work at the Princeton Plasma Physics Laboratory. I am the head of the Tritium Systems.
My name is George Ascione. I'm with the Princeton Plasma Physics Laboratory. I'm the head of the Health Physics Division and the Nuclear Materials Safeguards Manager.
My name is Adam Cohen. I was with the Princeton Plasma Physics Laboratory as the Deputy Lab Director up until November, and now I'm on assignment to the U.S. government. The Princeton Plasma Physics Lab's primary research is on fusion energy and developing fusion. There are many applications for the types of science that go into the basis for fusion energy, including the use of plasmas for various things and potentially neutrons for various things. Given the need from the world to make medical isotopes, particularly technetium-99m, could you do it with fusion neutrons? And the answer was yes.
The patent gives us the ability to make a medical isotope that's in great demand in the United States, actually throughout the world, and that is technetium-99m. This is the material that's used in 2/3 of diagnostic applications. So we, this team, actually proposed a new way of making this material.
What we really started to focus on is how could we produce that high energy gamma in a small environment, a non-cyclotron type environment, a non-reactor type environment. And that's where we really came through a little, part of our breakthrough in developing that high energy gamma ray that would knock the neutron out of Moly 100 and give us Moly 99.
Our technology actually will be able to distribute this material much more widely than it is now. And we believe this will be helpful to many people who need this type of diagnostic medicine.
We're dealing with short half-life material, so time is of the essence. And this material is traveling back and forth on our roads in the United States daily, round the clock, up and down the New Jersey Turnpike.
Part of the problem with getting it to some remote areas is because of the half-life, the shipping is going to be a hindrance. And so if you could make it locally, then that would be an advantage.
This process that we're proposing would in theory give a hospital a device the size of a refrigerator that could produce the material in your basement.
To develop fusion energy, it's a long process. But along the way, we find things that actually can help society. And this, we believe, is one of those things.
Throughout my career, I've done a lot of research. I've been involved in other patents. But this recognition is new and exciting, and I'm just glad I could be a part of this.
This is a tremendous honor to win this award, and it's very exciting. And now we have a patent that potentially can be further developed and really change the world in terms of medical technology and medical isotopes availability. So I think this is illustrative of exactly what we want to see throughout the whole complex. This is what innovation is all about.
I live in New Jersey, and this award is sort of, homegrown for Edison, and I'm really excited that I'm in this room where Edison did so much of his work.
I want to welcome to the stage Princeton Plasma Physics Laboratory inventors Charles Gentile and George Ascione.
First, on behalf of George, myself, and Adam, thank you very much. Thank you to the R&D Council. And I want to thank Lori Bagley, a lady who works with us, who's been very helpful in making this thing happen. But the most important part of this is that we will be able to bring a diagnostic medicine to parts of the world that historically were not able to have it. And that is something that we worked hard on, and we will continue to work hard on, and we saw the problem a little bit differently. Instead of producing a large amount, we were able to produce small amounts that were easily distributed and got to places where it needed to be. So thank you very much for this recognition.